Hello everyone. In last class we have finished Boyle's law, and in today's class we are going to learn Charles' law. Okay, what is that? Charles' law. There are basically two laws which has given by this chart. Out of that, first one is what? Let's learn. So this is the first law, that is Charles' constant pressure law. Charles constant pressure law. Right. Okay. So before going ahead, let me tell you one thing, that in Boyle's law we have seen, in Boyle's law what is constant? Temperature is constant. In Boyle's law, temperature is constant. Left what now? Pressure and volume. So there pressure is inversely proportional to volume at constant temperature. This is what your Boyle's law. Now in Charles' law, what is constant here? This is pressure is constant. In first law we are learning, that is constant pressure law. Now what is left? Volume and temperature. So according to this, volume is directly proportional to temperature at constant pressure. So what is the statement of this law? See here, the volume of a given mass of a gas the volume of given mass of a gas is directly proportional is directly proportional to the absolute temperature. To the absolute temperature. That is nothing but this volume is direct proportional to temperature. Boyle's law, inversely proportional to volume at constant temperature. This Charles law is direct proportional. One time constant pressure, one time constant volume. So here you see, volume is direct proportional to temperature. In bracket I am writing at constant pressure. Got it? So now this T is there. If I will say K is a proportionality constant, I'm adding. Let us suppose this is a K into T, where K is what here? K is one constant. Then can I say that P by T is always constant, and therefore P1 by T1 is equal to P2 by T2 is equal to always constant. This is what Charles' law at constant pressure. Got it? So V1 by T1 is equal to V2 by T2 is always constant. Understand? So it is very simple. That is Charles' law at constant pressure. What is two things left? Volume and temperature. They both are directly proportional, and you have to keep pressure constant. Yes. And then V is equal to K into T, where T is a constant, and then V by T is constant. Therefore, V1 by T1 is equal to V2 by T2 is equal to V3 by T3, and so on. How many want? Is always equal to constant according to the Charles constant pressure. Okay, so pause the video, note down this. Okay, next. Now, see here, suppose if P0 is volume of gas at 0 degrees Celsius, yes, and suppose Vt is the volume of gas at T degrees Celsius. Okay, there are two volumes we have considered. One is what? P0 at 0 degrees Celsius, and Vt is what? At T degrees Celsius. Then from this law, you can see here P0 by 273.15. Yes. How? Wait, let me do one more step for you so that you will understand better. Can I write like this? According to our law, we know P1 by T1 is equal to V2 by T2 is equal to V3 by T3, and this is always equal to constant. Here P0 divided by what? 0 degrees Celsius. T1 is what? Is equal to Vt divided by T degree Celsius. Clear? है ना? P1 T1 is equal to V2 T2. So here you are getting like this. Now this is V0 divided by, this is 0 degrees Celsius, we have to convert into Kelvin. So I am writing like this: 0 plus 273.15 standard value I am taking to convert into Kelvin. This is equal to Pt divided by T plus 273.15. Any doubt? This is we know, and therefore I am getting now P0 divided by 273.15 is equal to Pt divided by 273.15 plus T, or T plus 273.15. Addition you can do, it was no problem. Okay, so T plus 273.15 I have written as a 273.15 plus. Got it? Okay. So now if I want Vt, now how I should get formula? See here, cross multiplication. देखो, cross multiply करो. V0 into bracket 273.15 plus T, yes, is equal to, or let this keep here only. So I don't want to transfer this because direct I am getting Vt. So here I am keeping this 273.15 as it is, and this side you are getting only Vt. Any doubt? Just I have transferred this to here and multiplied, and this term as it is I have kept. So let's do now what we are getting. So I am getting something like this. 273.15 V0 divided by its denominator. I am separating at the same time, plus V0 into T divided by 273.15 is equal to Vt. Now this and this will get cancelled, and I am taking common V0. If I am taking V0 common, what is left here? Nothing, means 1, plus here what is there? T by 273.15, and this is equal to what yours? Yes. So you got this formula. I am writing here last formula. You can write with me. What is that formula? Just reverse it and keep it in a box. So after this formula you write in this box whatever I have written. So I am getting Pt is equal to P0 into bracket 1 plus T divided by 273.15 is what? Volume at temperature T degrees Celsius. P0 is what? Volume of gas at 0 degrees Celsius. Pt is what? Volume of gas at T degree Celsius. And then you got Pt. Pause the video, note down this. If you are out, ask me. Okay, next. Now see here, we got the last expression like this. We got like this. Vt is equal to V0 into bracket 1 plus 1 by 273.15 into T. Yes. Now this part, if I am assuming it as alpha, assume karo this is alpha, then what we are getting formula, we are getting like this. Pt is equal to V0 into bracket 1 plus alpha T. Yes, what we are getting? Pt is equal to V0 1 plus alpha T. What is alpha here? This is not coefficient of linear expansion. Here alpha is what we can say. What is alpha here? Coefficient of or volume coefficient of gas. क्या बोलेंगे? Volume coefficient of gas. Volume coefficient of gas. Now, if you will find out the formula from this, you see here Vt is equal to V0 plus V0 alpha T, and therefore Vt minus V0 divided by V0 T is equal to what? Alpha. Yes, we are getting what? Here it is alpha value. And alpha can I write like this? Alpha is equal to 1 by 273.15, which is equal to 0.00366, 0.00366 per degree Celsius. Okay, right? You can check this alpha value and this whatever I have written on the board. Clear? Next, one note point. If V1 is volume of gas at T1 degrees Celsius and V2 is volume of gas at T2 degrees Celsius, then what we are getting alpha here, you are getting alpha is equal to P2 minus P1 divided by P1 T2 minus P2 P1. याद रखो How we are getting this? Just in this formula, if you will substitute all the values, that is something like this. So P1 is equal to V01 plus alpha T1, yes, and V2 is equal to V01 plus alpha T2. If you will solve this, you will get alpha is equal to this formula. Understood? If now, see here, if D is the density and T is the temperature, if D is density of gas and T is temperature, then this density is inverse proportional to temperature. Yes or not? Yes. As the temperature increases, density decreases. As the density increases, temperature decreases. Vice versa, inverse proportional. So therefore, here you are getting, that implies dt is equal to always constant, and therefore d1 t1 is equal to d2 t2 is always constant. This is what the law in terms of density. Clear? Density and temperature. Right? So pause the video, note down this all. Okay, next. Let's plot the graphs. How will be the nature of these graphs? Suppose I have plotted P versus T graph. Okay. This is the origin. And if I will plot a graph against this volume and this temperature I am taking, here I am taking 3 degrees Celsius on x-axis, and on this y-axis I am taking volume, then the nature of this graph will be something like this. Okay. And if I will find out the slope, which is making angle here, this is angle theta, and which cuts at this intercept at minus 273 degrees Celsius. This point is A, this point is O, and this point is. Now, if we will take slope, as you see, this is theta, means here also this angle is also theta. So if I am giving name this point as a C and this point as a D, then in this triangle CBD or BCD, BCD ले लेंगे, triangle BCD, what you will get, tan of theta is equal to CD by BC. Yes or not? CD by BC. Okay. Similarly, you see triangle OAB, triangle OAB. In triangle OAB, in this what you are getting, tan theta is equal to OA by OB by OA, है ना? OB by OA. Yes or not? This is opposite by this is adjacent. So OB by OA. So you can keep OB as it is. but this OA, you know, OA is how much you are having? 273. So if I am taking this as equation 1 and this as equation number 2, you can equate these two. What is that? CD by DC is equal to OB by 273. Any two things is given, you can find out third one from this formula. Is that clear? This is the graph 1. You can give this graph as a number 1, and this is volume versus temperature graph. Volume versus temperature. If like this graph they are clear. Note down. Okay, next. Now second number graph. If you are having graph like this, how to find its slope? This V and this is T on this axis, and they have given this as a theta. Then in this case you are getting slope is equal to what? Change in volume by change in temperature. Next, one more graph is there, that is volume versus temperature only. This is volume and this one is temperature. If this one is angle theta 1 and this one is angle theta 2, then this is for pressure P1 and this is for pressure P2. So what is the meaning of this graph? In this graph, there is two reading of pressure. Which graph I am talking about? This third graph. Okay. So first what we did is for this graph or for this line, we have kept one pressure constant and we have plotted graph volume versus temperature. For this second P2 and volume and temperature graph. So here is angle what? Theta 1 and theta 2. If this is the case, then definitely what you can conclude from this, P1 is greater than, okay, right? So note down these two graphs also. Okay, next. Now this finished what? Charles law at constant pressure. Now next one, that is second law, Charles law of constant volume. Charles law of constant volume. Charles law of constant volume. Right? Another name for this law is Gay-Lussac's law. What is the another name? Gay-Lussac's law. Okay. One minute. Here it is double. Okay. Gay-Lussac's law. Right? So you see here what it is saying, Charles law of constant volume. Means in this volume is constant. What is left? Pressure and temperature. So how we can make the statement at constant volume here, at constant volume, at constant volume, pressure of gas is directly proportional to temperature. Yes, sir. Temperature increases, pressure increases. Temperature decreases, pressure decreases at constant volume. So can I write like this? Pressure is proportional to temperature in bracket at constant volume. What is that? At constant volume, right? So, so here it is P by T. That is, you can write here also P is equal to KT, where K is constant, and therefore P by T is equal to constant. Here K is what? Constant. So always P by T is equal to constant, and therefore T1 by T1, T1 by T1 is equal to P2 by T2 is always equal to constant according to this law. Clear? So what we have to keep constant here? Volume. And what are the two things? Pressure and temperature is directly proportional to one another. Now similarly, you see here, if P0 is pressure at 0 degrees Celsius and PT is pressure at T degrees Celsius, then I am directly doing now because already I have derived in volume, so no need, you can do it easily. So direct P0 by 273.15 is equal to PT divided by T plus 273.15. Do the cross multiplication and you will get formula, that is PT is equal to P0 into bracket 1 plus 1 by 273.15 into, and here also this PT is equal to P0 1 plus beta into T. The same like previous one. Okay. So what is beta here? Again 1 by 273.15, and beta is called pressure coefficient of gas, and it is also having same value. Pause the video, note down, and ask me out if you have any. Okay. So next. So from the last equation, what we got, you can write like this also. Beta is equal to what? Pt minus P0, Pt minus P0 divided by P0 into T. And also beta is equal to how much? 1 by 273.15. This is equal to 0.003666 per degree Celsius. Clear? Next, note point. If P1 is pressure of gas at T1 degree Celsius and P2 is pressure at T2 degree Celsius, then beta is equal to P2 minus P1 divided by P1 T2 minus P2 T1. You know how you got this. You can do yourself also if you have doubt. right? Just substitute in the formula and you will get this beta value. And what is beta called as? Beta is what here? Pressure coefficient of gas. So if, let me take you back for 2 minutes. You see here, as in this Charles law, at constant pressure we can say, you see you got the same thing, and you, I have derived also here how you got this, right? And then 1 by this 273.15 is alpha, then V not Pt is equal to V01 plus alpha T, then alpha is equal to this, then alpha for different volume of gases is this, and alpha is what? Alpha is what? Volume coefficient of gas. Same thing here also, you see this P naught and Pt, and Pt is equal to P naught 1 plus beta T. Almost all are similar model. Just instead of Pt you have to replace Pt, instead of P naught you have to replace P0, and at the place of T1 T2 is same. Okay, understood? Is there any doubt? Okay, note down this. Okay, let's move ahead. Now let's see the graphs in this case. Same model, okay, same pattern as it is. So first I am taking now here pressure versus temperature graph. There what I did, I have taken volume versus temperature graph. The first graph I am taking as it is. If it is possible, I will plot all the graphs in one page, okay, so it will be convenient for you. So this is your first graph. Like this. Then here is your second graph. That is also pressure versus temperature only. And here is the third graph. Okay. Same pattern graphs are there all. Same like volume temperature and pressure temperature. Same pattern. So here it is your intercept. This is O, origin. Here also origin. And this is, as it is, how much is minus 273 degrees Celsius. And this is point A. This one I am giving as a B. And all are pressure versus temperature graph. Here also pressure versus temperature. And this is pressure. And here it is temperature. This angle is what? Theta 1. This angle is what? Theta 2. And here it is V1. This is what? V2. So for this first graph, let's take the slope as we have learned in the previous case. This is your C point, this is your T point, And for this, direct I am writing now only one formula. This is also what? Theta only. As this is theta, this is also theta. So tan theta is equal to OB by 273 is equal to CD by BC. है ना? देखो इस triangle में this tan theta is what? OB by this, opposite by adjacent. Here also opposite by adjacent. So CD by BC. Next, in this case, if this is a theta and you want for this slope, then you know it is very simple. That is what? Delta P by delta T. Now delta P, not delta V here. Delta P instead of delta V in a previous case, because this graph is pressure versus temperature. Now, in this case, what you are getting? Volume V1 is greater than volume. Okay, what you are getting? Volume V1 is equal to, or volume V1 is greater than volume V2. Yes. Okay, so note down these all graphs. Next one small note point I want to give. Finish it first. Pause the video, note down. Okay. So next, one small note point. If two vessels of same volume note point, if two vessels of same volume containing a gas at T1 Kelvin and T2 Kelvin. T1 Kelvin and T2 Kelvin. Temperatures and at pressures P1 and P2 are connected by a narrow tube. Then common pressure this one we have learned in Boyle's law also. Yes or not? This one we have learned in Boyle's law also like this. But not in terms of common pressure. I think we have taken their common volume. Check it. Or common temperature, whatever it is. Right? Check it once there. So if two vessels of same volume containing a gas at T1 and T2 Kelvin temperatures and at pressures P1 and P2 connected with narrow tube, then common pressure P is equal to what you are having P1 into T2 plus P2 into T1 divided by P1 plus P2. Keep this formula in mind. Okay. Sorry. This is T1 plus T2. One minute. Here it is what? T1 plus T2. Okay. So common pressure formula is what? T1 T2 plus P2 T1 divided by T1 plus T2. When two vessels of same volume containing a gas at T1 and T2 Kelvin temperatures and P1 and P2 pressure. That is what your common ratio. Okay. So try to revise this carefully one more time. Okay. In tomorrow's class, we will finish this gas topic. So ideal gas equation and all these things, so that this gases will also finish. Okay. So read, revise one more time. If you have doubt, call me, and let's stop here. Enjoy the day. Bye.